you.
So I just started recording. So I've got Kory Goldsmith and Daniel Harnden, and they're going to talk to us about the bee waggle dance. And they're going to talk to us a little bit about how we can understand the dance and where our bees are foraging. And they're also going to share a little about how they were able to find a pollen source by analyzing their bees waggle dance. So Kory, I'll pass it over to you.
Okay. Thank you so much. I appreciate it. Let me go ahead and get the, let me see. That one. See if this brings it up. Can folks see that? PowerPoint? Can you see that? Okay, cool.
Yes.
And I'm going to just move this out of the way. All right. Thank you. Thank you for inviting me. And Daniel is my, he's my technical support here. So if I get lost in what I'm doing, he'll give me a hand. Again, my name's Kory Goldsmith, and I've been keeping bees for over 30 years. I think I've become really, I think it's been the last few years since I've really started educating myself about bees. That's when we started having a lot more hives. We went from having about two to 5 hives on and off to now we have between 30 and 100 hives, depending on what time of year it is. So in that process, I've really tried to start thinking like a honeybee, which I think is very difficult to do because we're so different. And that's really why I titled this, What Did She Say? Because it can be very difficult to figure out what your bees are talking about. So why is it so hard to think like a honeybee? It's for a lot of reasons, obvious reasons, but bees live in very different conditions than human beings do. Obviously, they live in a dark place. They fly to get around versus human beings that live in lighted locations. We use sound and sight to communicate. Bees use sound and odor to communicate. So those are the kinds of things that really can make it difficult to understand what's going on with your bees. And I know every beekeeper here, I think, has gone into their hive and tried to figure out what's going on and just been completely confused. So what I'm going to talk about tonight are some tools that I think everybody has access to that they can use to help them understand where their bees are going, what their bees are doing, and then and then sort of pull it all together in a situation where we were able to really use that information, and it was really kind of fun. So the first thing I wanted to talk a little bit about is where can your bees forage? And what this slide has is just our bee yard, and well, I'll talk a little bit about the distance that bees forage. But this is just from Google Maps, and we just built in 1, 2, and 3 mile radius, a couple of other colonies or other bee yards that we've got. But this is sort of the bees' view of the world, obviously much higher. I'm just gonna have to, there we go. And versus the street view. So this is the Google Street View. This is what we can see as humans, right? When we're walking down the road, when we're driving down the road, it's extraordinarily limited versus what the bees are able to see, again, at the same location. So from the road versus up above. And so again, this is one of our bee yards. And what's interesting and the point I'm trying to make really is what sort of forage is available to your bees. And pulling out a little bit, the forage that's available, pine trees, the dark green is pine trees, not great forage. The brown or gray are deciduous trees. So, and these photos are taken in the wintertime, so there are no leaves on the tree, so that's how you know these are deciduous. But those are great sources, obviously. We're just coming off of the poplar flow. Early in the season, you've got maple. A source of honey that I think a lot of us forget about, again, it's up in the canopy, is poison ivy. And then in addition, you've got fields, various different fields, and not all fields are created equally. This is the other location that I mentioned. Again, you can see the pine trees. You can see there's not as much deciduous, a lot more field areas. So something we have discovered between those two, the differences between those two locations and the nutrition that's available to our bees at those two locations. Where we are more forested, we have a great, strong poplar flow in the spring. As we move into the summer and the dearth and then go into the fall, we really don't have much of a flow in the fall, versus this yard seems to have far more forage in the fall, and we believe it's because of these fields. A lot of them are abandoned, and so their forage goes later into the season. It's also more, I think, helps the bees that it's more diverse. So my point is really not so much whether or not one bee yard has better forage than another, but just what's available to your bees. What's a tool that you can use to figure out what might be available to your bees? Some other tools that we can use. We are fortunate we've put an observation hive. This is the observation hive that's in our house. This one happens to be it's actually 12 medium frames. It's 2 deep on either side. The entrance is through the wall here. You can't quite see it down there. So the bees come in through the bottom and they work their way up. This is, we've had this hive on and off for about 4 years now, 3 or 4 years. At this point in time, you'll notice there's no brood. So it was actually queenless until yesterday, until today. Today is the first day we saw the queen, and I've got a picture just because it's a lot of fun. But the bees will come in down here, they'll enter down here. This is the area where they will do the dance, where they'll do waggle dancing. The brood tends to be on the other side and also in between. But it's just a really neat tool. We've watched bees swarm. We've watched bees build queen cells. It gives us a sense of when the flow ends. So it's just a really useful tool. And this is, again, I'm just kind of really excited that the queen has shown up. Just saw her this afternoon. She was laying and seems to be good and healthy. I'm going to digress a little bit further. Something else that you can see with an observation hive. One time we actually had 2 queens in the hive. This was the mother queen. She really was not well liked by the bees, and so they created supersedure cells and raised her daughter, who was extraordinarily well loved. And the 2 queens lived in that hive together for months before the mother just finally kind of just disappeared. So just going back to some tools that you've got at your disposal and that you can use for figuring out what your bees are doing. And I'm happy if anybody wants to ask questions along the way, I'll stop, but otherwise I will keep talking if that's okay. So the dance language. The dance language is a fascinating behavior that honeybees use. It was discovered and described by Carl von Frisch in the early 1920s. It was highly controversial. At the time, people thought that bees communicated using taste or odor. And it was, von Frisch actually received a Nobel Prize, not until the early 1970s, but he received a Nobel Prize for describing this behavior. So a lot of the information that I have tonight comes from von Frisch. It also comes from Dr. Tom Seeley. I think a lot of folks are familiar with him. And also David Tarpey, our own Dr. David Tarpey at NC State. There's a lot of really neat research out there, and it's a lot of fun to dig into it now and then. So the other point I would make is that, let me go back here, I'm sorry, that the waggle dance communicates a lot of information. It's distance, it's direction, it's quality of the resource. And honeybees will use the waggle dance for all 4 of the substances that they collect. So for nectar, for pollen, for water, and for propolis. And they also use it, so those are for the resources they collect. They also use the waggle dance on swarms when the scout bees are trying to convince the colony to go to a particular location as a new home. So in a colony, and this is a schematic of an observation hive, but within a colony, where do the bees dance? And again, if you assume that this is the entrance, typically they dance near the entrance. And there's a correlation between the distance from a colony to this resource and the distance from the entrance to where they dance. So bees that have found a resource that is near the hive tend to do their dancing near the entrance. Bees that have found a resource further from the hive tend to do their dancing further from the entrance. And all of this is qualified, as you know. Bees don't always read the books. They don't do exactly, but this is collectively the information that's been able to be put together. It's really interesting because I was looking at something, I don't have a slide on it, but I was looking at something the other day that described where bees that are dancing because they have a food source, pollen or nectar, tend to do the dancing near the entrance, whereas bees who are dancing because they are bringing back propolis or they're bringing back resin tend to dance kind of on the edges and even up higher up into this area. So I don't have a lot of information about where bees who are bringing back water dance, but I do remember a description that I think it was Tom Seeley described, that one of the most excited dances he ever saw was a bee bringing back water during the wintertime, and the bees were really, really thirsty. So the dance itself varies depending on the distance, again, how far away the resource is. So for food sources that are nearby, and nearby I mean like within 50 feet of the hive, the bee actually just does a circle dance. So she'll run one direction and turn around at the top and run the other direction, and turn around the top and run the other direction. As the distance to the resource increases, the dance kind of elongates, kind of starts to develop into a figure 8 until you get to what we think of as a classic figure waggle dance, and actually includes waggling. So there's no waggling in this figure 8 dance or the circle dance, but as the distance increases, eventually the waggles begins to come in. And I think that occurs really at about 300 feet is when the bee will start waggling, and she will only waggle in one direction. We'll talk about that a little bit later. So this is the classic configuration, what we think of when we're thinking about the waggle dance. You've got the forager. She is shaking her abdomen vigorously as she moves across the comb in one direction. This illustration, she's moving towards the bottom of the comb, and she'll come back around. She has a group of bees who are following her very closely. Sorry about that. So she's got some bees who are following her very closely, and they are. So again, remember, it's dark. It's dark inside the hive, so they don't see what she is doing. They don't see her waggle. They hear it and they feel it. So she's not only waggling her abdomen, she's also she's contracting her flight muscles, and she's buzzing. So they are hearing with their antennas, and they're hearing and feeling with their feet, because this causes vibrations on the comb. And so we've got some video where you can actually watch them following one of the dancers. I'm sorry, I'm just checking some of my notes. As the distance increases, the waggle dance actually degrades. I don't know if that's the right word, but it it changes so that she's no longer doing a true figure eight. She is just running downwards.
Laser.
Pardon?
Laser. I can't see your pointer.
Okay, you're right. Sorry. She's moving down the comb, and generally speaking, for every second of waggling, it equals approximately 1 kilometer. So a kilometer is 0.6 miles. So in my mind, I just round down. So for every second of waggle, it's half a mile, approximately. Something that's really interesting is that the distance that she is traveling on the comb is not necessarily, it's not just distance in terms of miles.
Yeah.
Sorry about our cat. It's really communicating as much as anything effort. So if there's a headwind, then she will spend more time waggling than if there was no headwind. If there's an obstacle that she has to go around. So she's really communicating as much as distance, the amount of effort that's needed to reach the destination. Something else that I think was really interesting that I read is that, and that goes along with this idea that what you're communicating is effort versus distance, is the forager will, when she's getting ready to leave and go out to the food source again, she'll fill up on just enough food to get her to that food source. So she's not going to fill up all the way. And obviously if it's nectar in particular, then she can use that to fuel her on the way back. But she's not going to fill up any more than she needs to get to the resource. All right. The other, I mentioned that typically the maximum distance that bees will fly. So by and large, bees will try to find resources that are nearby, uses less energy. And so I think there was a study that Seeley did and looked at over the course of a summer, like about 1,800 dances. And the majority of those, the most common dance was for a location that was within half a mile. And then as it went out from there, the longest dance that he observed or that they documented was actually 6.5 miles away. And one of the things that they noticed, because they looked at it over a summer, is that the bees tended to use resources near the hive earlier in the season. And then I think as the resources, as their opportunities and the types of flow that was out there diminished, the bees would go further and further. And so there was an instance where the bees flew 6.5 miles. And when they went out to locate what the source was, it was a field of blooming alfalfa, and that was late August. So
Move on.
So anyway, this is a video that we took 2 or 3 days ago, again, using our observation hive. And the reason I brought this up is this is one of those bees who is apparently going an extraordinarily long distance for food. We counted, and she does her waggle for almost 14 seconds. So I have a hard time believing, especially this time of year, that bees are traveling essentially 7 miles to get to a resource, but that is what we found in this instance.
Just wanted you to show the bees following her.
The other thing that I think is useful to see is the, here we go, the bees who are following her. So, and I'll talk about this a little bit later, but these are what are known as unemployed foragers. There are 2 types of foragers, employed and unemployed. And the bees who follow the waggle dance are not other foragers. They're bees who are figuring out where they need to go out to forage. So there's a whole lot of interest in what she's doing.
And then move on.
So we've talked about the distance and how that is communicated. Another factor that's communicated is the direction. And if you think like a bee, you are always thinking about where the sun is. And the bees always orient the sun as being towards the top of the comb. Excuse me. And so I'm going to actually go through these a little bit. I like this slide the best. I'm going to use this to illustrate. So you can either think about that as far as the bees are concerned, the sun is always towards the top of the comb. Away from the sun is always towards the bottom. And the goal is relative to the sun. So a lot of the literature describes that in terms of degrees off of the sun. But as you can imagine, but for me, I actually find it more helpful to think of this as a clock face. So the sun is always at 12 o'clock. And the direction the bee is headed is some amount off of noon. So in this instance, if the forage is 40 degrees from the sun or away from the sun, then it's this direction. So, and the other thing, not generally speaking, when you are interpreting the direction the bee is describing, if the direction is, again, clock face helps me, between 9 and 3 o'clock, then the forage is some version towards the sun. It's some direction generally towards the sun. If the dance, as she dances on the comb, is more between 3 and 9 o'clock, then it is the source is away from the sun. But the beauty of this, but also I think what makes it hard to translate on the ground for humans, is obviously the sun moves across the sky during the day. As what the bees do, that is, in my mind, genius, is they always orient that the sun is straight up on the comb. So this is just trying to illustrate several food sources in relationship to a hive. So there's a food source A that is directly towards the sun, food source B that is off at 10 o'clock, not between 9 and 10 o'clock, and then another food source that is at directly away from the sun. So using the clock face analogy at 6 o'clock. The dance and the dance that takes you, that this describes, is waggling straight up on the comb. And so that would describe food source A.
Just gonna tell them, I gotta go with chase.
The food source that is away from the sun, directly away from the sun, would be C, and the waggle dance that is describing between 9 and 10 o'clock is food source B. So a couple of other things that I think are fun to know about recruitment and the whole recruitment process. I think I mentioned that there's something called unemployed bees. So there are essentially two types of bees. There are the bees who are actively engaged in foraging, and then there are bees who are foragers. They're in that portion of their life, but for whatever reason, either the source that they had been going to the day before has played out, or they've just grown into becoming a forager. They wake up in the morning and they don't have a food source to go to. So the other thing is, not all foragers dance. Only those foragers who perceive that they have a good food source, one that is would be good for the colony to send more foragers out to, those are the ones who will dance. And active foragers don't pay attention to other foragers who are dancing. only unemployed foragers pay attention to the dancers. I mentioned that they hear it. They also get the dancer, if it's nectar, will give the bees a taste of the nectar, and bees are extraordinarily good at distinguishing which nectar sources are higher in sugar versus ones who are lower. They're apparently not as good as at distinguishing the quality of pollen. The other thing that the dancer will do is the better food sources, she will do more rotations or more cycles in her dance. So a really good food source, she might dance 6 to 12 times. A less a food source that she's not as excited about, she might dance a couple of times before finishing. She'll unload the nectar and head back on out. Okay, so getting to the time when we pulled all this information together and found an unusual pollen source. So we were out in the bee yard. Every colony in our bee yard had bees coming back with a very unique pollen. And it's this particular pollen. You can see that, they had the pollen basket on the hind leg, but it also had these crazy little flags. We referred to them as danglies. I'm sure you can tell that's a highly scientific term, but we were seeing this in every last colony we had. We were seeing it also in our observation hive. And so we got some video, and as you can see,
1001, 1002, 1003, 1004.
So this bee is dancing a little over 4 seconds. She's going straight down on the comb. She's got a lot of interest. She's attracted a lot of interest. So what was really nice about this are two things. One is this is fairly far away, so 4.5 seconds. Again, hang on, stop this. 4.5 seconds indicates a fairly distant resource. It's also straight down on the comb. So what we did, we went outside to our bee yard and we looked directly towards the sun. That would have been if she'd been dancing straight up. But we were also able to, because of that, determine that the direction was exactly away from the sun. So where the shadows were. We went outside, looked at where the shadows were, and understood that meant that was the direction of the resource. We've overlaid this with the compass points. In our yard, west is off of that direction, so the direction of the resource was west and a little bit north. So it was west and a little bit north. That's where those shadows were pointing.
And the dance was pointing.
And the dance was pointing. And you could also see that we did the calculation. 4+ seconds, 4.5 seconds times 0.6 was about a little less than 3 miles. So we knew that this resource, this unusual pollen source, was a little less than 3 miles west-northwest from our house. Using that information and Google Earth, again, we because Google Earth has a scale, so you could lay this out, and for each second is a kilometer. So 1 second, 2 seconds, 3 seconds, 4+ seconds. We were also really fortunate in this instance that there's a road near our house. It's Crawford Dairy Road that runs pretty much right on that directional access from our house. So yeah, we had to, because we're human beings, we can't fly there. We had to go around on the roads. But we knew from looking at the map that we were going to be able to get out near where this pollen source seems to be. We're looking at the map. It's like, it's not those pine trees, but maybe it's something a little further on. And it turns out it was a little further on. And when we got out there, what we found was a field of millet. That's a really strange thing for bees to be on because it's a wind pollinated plant. But when we got out there, every single head of millet, and it went as far as, is it 20 acres of millet, had bees on it. And we knew this was the source that our bees had. Maybe these aren't our bees, but this is the source of the pollen that our bees were coming back with because of these strange little danglies. And you can see them on her there, and then you can see another bee flying by, and she's got the similar danglies. So it was just really cool to take the information that we could see that the bees were communicating in the hive. They're not telling us this information. They're telling, she's telling her sisters, those foragers are telling her sisters, but we were able to take that information using some tools that we had at hand to translate it and actually locate that source.
Come back to the map.
Let me stop that. Oops, I accidentally,
Just hit,
let me go back to the share screen.
Yeah.
Sorry about that. I seem to have messed up on the sharing screen. Can you help me, dear?
oh, just take questions at this
Okay.
point.
I guess this is as good a point as any to wrap up. I think one thing that's kind of interesting is we tried the following year. So this was 2019 when we did this. We tried looking for or looking to see if our bees were on a similar source in 2020. It was September when this occurred. We never found any. I think I saw half a dozen bees coming back with millet pollen. So I don't know if it's because they didn't find that resource in 2020. They had other resources to go to. I think one of the questions that I wonder about a lot is how is it that all the bees in our bee yard in 2019 found that resource, and yet either none of them found it in 2020 or they weren't interested in what they found in 2020. So that's pretty much everything.
This is great. There was a question, but it was answered in the chat where the question was about if you've noticed any, let's see, sorry, scrolling up here. If you had noticed any interference, if you're using plastic foundation and if that interacts with the vibrations. But Phil said that Tom Seeley was asked this at one of the state meetings and he didn't see a difference. But have you observed anything related to that?
We haven't, and we have plastic foundation and we have wax foundation. But I remember I think we may have been at the same talk, and Tom Seeley indicated that he was not able to find any difference between the ability of the bees to communicate when it was plastic versus wax foundation.
And it's plastic in the observation hive, and we found the millet bill.
Yeah.
And something that I heard on a podcast a few months ago was that, like, if there is some type of a unique structure or something, I guess, visual near a pollen source, that the bees are more prone to use that source. Like if you put a chair in a field of something, like then they kind of use that as their navigation. Like, have you in analyzing your waggle dances, like have you noticed that they are preferring areas that have like some type of structure nearby that they're using potentially?
So no, and this was, so by and large, we can't really find the location. This was unique. We were able to, so we could look at the waggle dance and we can say, this pollen source is a mile away, and it's north of here. I was looking at one this afternoon where the bee was waggling for 2 seconds, and the direction indicated it was north of our yard. but I didn't go there. So it's really hard to actually go and find the source that they're on. We had an instance years and years ago where we saw bees coming back and they had like a white stripe on their head. They all had little white stripes, like little mohawks. And just by coincidence, we were wandering around in the woods or near a creek and found jewelweed. And the bees were going into the jewelweed and the pollen was wiping their heads and they were coming back out. So it's a really neat tool to use. It's, in my experience, it's very difficult to find the actual pollen source that they are
So
on.
tell them all the factors that went into finding this one.
So Daniel just asked me to just repeat all the factors that went into finding this one. So it was A, unique pollen source.
Dangles.
B, it was easy to decode because it was directly down on the comb. We happened to have a road nearby that ran directly, parallel that direction. And the source itself was right off the road. We could get out of the car and we could go to the source. If that source had been 100 yards off the road and something had been in between, we wouldn't have been able to find it. So it was really a unique opportunity.
Awesome. I saw a few questions came in. One is, did you build your own observation hive? And the other question I'll then go down is, did you make the 3-mile circles in Google Maps or Google Earth? And how did you find that feature if that's what you used?
So I'm going to pass this along to Daniel because he is both the carpenter and the artist.
So I didn't make the observation hive that you saw, but once I had that one, I used it as a pattern and I have copied that one over and over again. It's a very good design. We don't have to take it outside when we manipulate it. We just take the glass cover off and switch out frames. So it's very nice. You can move it, but you don't have to.
In the concentric circles.
The concentric circles, you don't get that in Google Earth, or Google Maps. But what you do get is you get a little ruler that tells you how many miles in each direction. So you can draw it out a mile and just kind of notice, oh, that's by the road or that's by the church. I actually drew those circles in Adobe Illustrator. But you still have good measuring tools in Google Maps that can tell you exactly where something is. And I saw a question about, 2 questions, one with white mohawks and one with bees with pollen all over them. The princess trees are blooming right now, and their flowers are like a long purple tube. And I don't know if the bees are going in there, but that's exactly what gives bees mohawks, is anytime they've got to crawl down a tube-shaped flower. Maybe Phil knows, but that could be what we're seeing. And the other one with
the
pollen all over. Go ahead.
So we've seen our neighbor across the street has chickens, and our bees will sometimes get into the chicken feed and roll around it, or some sort of artificial pollen. That's when they tend to come back and sort of be covered all over. I don't think it's very resinous, and so I don't think it packs easily on their pollen baskets.
And the other thing I saw was I was watching honeybees collecting nectar on blackberries. And so they were intending to collect nectar, but they were crawling around in the blackberry flower. So they were getting fairly pollen covered, but it wasn't the intent. The intent was to get nectar. But that bee every once in a while would kind of pull back, and she would, brush herself off with her legs. And so she was getting a tiny, tiny amount of pollen, but it was mostly because she was just rolling in the flower.
Interesting. Any other questions? I mean, all of the illustrations you had in your presentation are like so meticulously done. I don't know if you found like some bee art or if you actually like created a worker and a queen and like,
Yeah, I drew those.
oh my gosh.
But you can tell I drew one worker, but then made the parts different colors. So, I've only got so much patience.
Hopefully you didn't draw every single piece of comb that's on there, and you'll just like copied and pasted a lot of it.
Yeah, it was mostly copying, pasting with a little repair work to get it to work out.
So we have some comments in the chat that this was fascinating. You're a wonder duo. So thank you for sharing. And any ideas on why bees don't make sourwood honey around here?
So they actually make a little, as far as I can tell. I've seen what I thought was sourwood honey. And I think that question came from Lori. But I think because it comes in June, the bees just eat it. They don't really put it up. And also we also don't have a lot of sourwood trees. We've lived up in the mountains where, where you've got giant sourwood trees and they're all over the place. And here we've got little scraggly sourwood trees. And, but I think they do make a little.
You just maybe can't get enough of a flow to put a super on and pop
I
it
feel
on
like,
right beforehand.
I feel like I've seen the sourwood bloom here at like mid to late June, and I feel like a lot of people might be extracting at that time, so that they might miss the little bit that comes in then.
So also when everything else is just shutting off, it's the shutdown period. The honey Kory and I are curious about is even later after sourwood, there's this dark chocolatey purpley honey that doesn't always come. And there's lots of theories. Some people think it's kudzu. And
we've looked at the pollen under a microscope and and then compared it, and it looks like it might be something called knotweed, which is just literally a weed in your garden, very low.
But I think isn't that in the same family as buckwheat, which also makes a dark honey. But that's what we want to know. We want to know
where that is. And I want to know if anyone has locust, because when I drive across Jordan Lake at the right time of year, there's tons of locust, but it's as though it starts, not Jordan Lake, University Lake. It's as though it starts at University Lake, but I don't see much locust in Chatham County. And that's a great bee plant.
Julia has some.
She has some, but she planted it.
Yes.
I thought it would be fun to put some hives over near University Lake right around that time and see if you could get locust honey. It's very, very light. We used to live up in the mountains and we would get locust honey.
Yeah.
Great. Any other questions? Andy says he lives near those locust trees.
Yes.
Yep.
Lucky Andy.
Yep. So one of the things that I think has been really interesting recently, and I think we just found out, is that the privet has been blooming.
It was a really
like a lot. I didn't realize. I don't remember seeing it before, but it seems to just be
going down now.
But I had really never seen privet blooming before, and it seems like it's really been prevalent this year.
Those big white bushes you see on the side of the road right now. Yeah. Yes, privet all over the swamp behind us. Bees working them a lot.
Okay, good.
And
I'm sure
Lori's,
everyone, every time you see a plant, know.
And Lori's saying that she hasn't seen much poplar east of the lake, and she's wondering if anyone else has noticed that. I'm on the west side of
east of University. Ours is done. Yeah. Ours is, the stuff around here seems to be on the very tail end.
Yeah.
Mm-hmm.
but something is still going because,
The bees are really excited.
yeah, the bees are coming and going, like almost like you're doing open feeding. So there's something out there. And I can still go into the hives without smoke or veil, and they don't care. But probably in about a week, when the flow shuts off, oh, they will care. And it'll be back to normal business.
This was fantastic.